polynomials. So if we have a polynomial p of x and it's divided by another polynomial, let's call it d of x, the result can be expressed in this way. So we've got p of x divided by d of x. The result will be the quotient, q of x, plus the remainder over the divisor. So this is like having a fraction, an improper fraction, and then what you can do is produce a whole number plus the remainder over the divisor. With our CAS, if we have the quartic here and we're dividing it by the linear here, then this can be written as x cubed minus 5x squared plus 12x take away 24 plus 40 over x plus 2. So this is the original polynomial. Here we have the divisor, what it's divided by. The x cubed minus 5x squared plus 12x take away 24 is referred to as the quotient. The remainder is 40 and the divisor is x plus 2. In order for us on our CAS to go from this quartic divided by the linear and get it into that form, then I just go number, fraction tools, proper fraction. Use CAS to divide that by this divisor and state the quotient, divisor and remainder. So here I've got the expression, the cubic up the top, there's the divisor, and so what we'd end up with is the quotient should be 3x squared takes 6x plus 7. The remainder is 9 and the divisor is x plus 2. Our CAS calculator, those steps, I go menu, number, fraction tools, and then I want proper fraction. I'm going to bring up the fractional tool here, and it's the polynomial 5 minus 5x plus 3 times x to the power of 3. So it's that cubic divided by the linear x plus 2. Hit enter, and there's our answer. So we've got the quadratic, 3x squared takes 6x plus 7. That there is referred to as the quotient. There will be a remainder of negative 9, and it's over the divisor x plus 2, what we originally divided by. And that's for that question there. Notice that I've got negative 9, I'm adding that to it. I'm putting that fractional part at the very end, and I've just made it a subtraction and a positive 9 on top, but you can see that it's the same thing. What to do is take a look at long division. We're doing it by hand rather than the CAS calculator. And to begin with, we're going to be applying what we call the synthetic method. So consider this quartic divided by x plus 2, and you can obviously see what the solution is. This is how we'd produce it. You begin by putting in a red L shape like so. You take a look at what the divisor is, and I've got positive 2 here, so the direct opposite of that is negative 2, so I'll place a negative 2. In this top line, I'm going to list the coefficients of that. So 1, negative 3, 2, and negative 8, and that's shown here. Okay, so at this stage, you should have nothing here and nothing there. And your very first step is to take this 1 and drop it down. I now go negative 2 times that 1 and put the result in here. I add these two together, so negative 3 and negative 2 produces negative 5. I repeat the steps, negative 2 times negative 5, and that result goes in here. I add these two together, 12. Now it's negative 2 times 12, and the result goes in here, negative 24. I add these two together, and that comes down. And now it's negative 2 times negative 24, the result goes in here. I add these two together, and there's the result. How is it that we interpret this? The last part is the remainder, and that leaves me with 3 other numbers. So the way I would read this is that it's x cubed minus 5x squared plus 12x minus 24 with a remainder of 40. So in other words, if I take the quartic x to the power of 4 minus 3x cubed plus 2x squared minus 8, and I divide it by x minus 2, that's what I get as a result, with a remainder of 40. So I can write it like this here. There's the quartic divided by the linear, produces this cubic plus a remainder of 40 over x plus 2. So that's how I perform long division with a synthetic method. I think these steps make things really clear, so I want you to pause the video just now and read those thoroughly and relate it back to the explanation which I just gave. Okay, so that's enough time looking at that. Let's take a look at this as a step-by-step example where it's easier to see. So I have the cubic divided by the linear x plus 3. My very first job is to establish what I refer to as being the zero. So I take a look at this expression here, and I'll look at that last number, positive 3, and get the exact opposite of it. So in our case, negative 3. I rule up the grid and place in the negative 3. I now write down the coefficients of the polynomial, so 2, 7, negative 4, and negative 21. And I bring down the first coefficient, so the 2 comes down. And in the next step, it's negative 3 times 2. The result is negative 6, and that goes there. I now add these two together and put the result here. And I repeat those steps. So there's the 1, so it's negative 3 times 1, the result goes here. In my next move, sorry, I'm moving all over the place, I add those two together to get negative 7. Now it's negative 3 times negative 7, and the result is positive 21. And then finally, I add those two together, negative 21 and 21 to get 0. And so what this tells me, I end up with this quadratic with no remainder. Remember the last part there is just the remainder. 2 here, what we've got to begin with for A is we've got this cubic divided by the linear factor x plus 2. So it's x cubed minus x squared, take 4x plus 4 divided by x plus 2. What is that equivalent to? So I'll begin by setting up my big grid, and it's shown there in red. You can see that we're dividing by x plus 2. So I'll look at the number there and take the opposite of it, so that would be negative 2, and I'll place that here. Remembering that at this stage you've got no entries here or here. So our first job is to take the first term, or the first coefficient here, and drop it down. So that's 1. Now it's negative 2 times 1, we put the result in here. We add these two together to get negative 3. Now it's negative 2 times negative 3, the result goes in here. Add these two together to get positive 2. Negative 2 times 2 is negative 4. Add the two together, and there's my 0. The very last number at the bottom here is the remainder. So in our case, what we see is that this cubic divided by that linear factor will produce a quadratic with no remainder. So I've got that cubic divided by x plus 2, and the result will be x squared minus 3x plus 2, and that's shown here. So what have I just worked out? This cubic divided by that linear produces this quadratic. Let's now take a look at D. Here's D. I've got this quartic divided by x minus 3. Notice that in this quartic there is no x term and there's no cubic term. How do I deal with that? So here's D. I set up my grid. I'm dividing by x minus 3, so I take the opposite of that number there, which is positive 3, and write it in here. So I've got x to the power of 4. I've got no x cubed, so I still need to show that column, so I'm going to put a 0 there. minus 7x squared. I have no x's. Again, I put a 0 in, and I'm taking away 18. Let's begin the process. The 1 comes down. 3 times 1 is 3. Add the 2 together, 3. 3 times 3 is 9. Add these 2 together, 2. 3 times 2 is 6. Add those 2 together, 6. Finally, 3 times 6 is positive 18. Add those 2 together, 0. So you can see with a remainder of 0, that means that when I take that quartic and divide it by this linear, there'll be no remainder, so it ends up nice and neat. And what you can see in this specific case, we will get x cubed plus 3x squared plus 2x plus 6. And that's written here. In F, it's a little bit different because you can see from A to E, all of these have just a 1 in front of the x. But now we've got a 5 in front of the x. And we need to treat this differently. Let's see the approach. So, my divisor is 5x take 8. I've got that minus 8 there. The direct opposite is positive 8. So that goes in here. I've got my grid drawn up. This is the cubic, and I'm dividing by this linear. So I have 5, I have negative 13, 28, and negative 40. The process is almost exactly the same. 5 comes down. But in my next line of workings, what I do is divide by 5. Why 5? Because I have a 5 in front of the x. So I'm going to divide by 5, and that will be 1. So now it's 8 times 1, and the result goes in here. Again, I add these two numbers together to get negative 5. But what I do next is divide by 5 to get negative 1. And now it becomes 8 times negative 1, and the result goes in here. I add these two numbers together, 20. I divide that by 5 to get 4. And now it's 8 times 4 to get myself 32. I add those two together to get negative 8. So, what have I found? This cubic divided by that linear will give me x squared minus x plus 4 with a remainder of negative 8, and we write that as being negative 8 over the divisor 5x take 8. Please note that in this last column, you don't divide by the 5. You just leave it there. Let's look at G. So for G, we've got this cubic divided by this linear. We set up our grid, and we look at the number at the end here, which is minus 5. The opposite of that is positive 5, so that goes in here. We take the coefficients of this cubic and write it at the top. And so now you can imagine that there's nothing here, there, or there. But let's follow the steps. We drop the 8 down. But now in my next line of workings, I divide by 4. And the reason for that is because of the 4 in front of the x in the divisor. So that becomes 2. 5 times 2 is 10, and that goes in here. We add those two together, 16. We divide by 4 to get 4. And now it's 5 times 4, which is 20, and that goes in here. Add these two together to get 12. Divide by 4 to get 3. Now it's 5 times 3, which is 15. Add these two together to get 2. So the remainder is 2, and there's no need to divide by 4. So I have this cubic by that linear. The result will be 2x squared plus 4x plus 3 plus the remainder of 2 over the divisor 4x take 5. And that's how I write it. 3. The traditional method of using long division. And I really encourage you to adopt this because it works out really well, particularly if you go on to study specialist maths later on. And also, I think this kind of method makes more sense and it will stay with you. Okay, so let's look at A. I've got this cubic divided by that divisor x plus 2. So I begin by setting up a red grid like so. Next, I'll place in the x cubed take x squared take 4x plus 4, so it's a top line of my fraction, and I place a divisor here. Here's my workings. I've got x cubed, and here I have x. What do I need to multiply x by to get x cubed? And the answer for that is obviously x squared. Next, I'll go x times x squared, and the result of that is x cubed. I'll place it here. But I've also got this 2. 2 multiplied by x squared is 2x squared, and I'll place it there. I'll rule a line. And now what I'll do is I'll take this line above and subtract from it this. X cubed take x cubed is 0x cubed. Negative x squared take away positive 2x squared is negative 3x squared. Negative 4x take away 0 is negative 4x. And 4 take away 0 is 4. So now I'm working with this. I've got x. What do I need to multiply it by to get negative 3x squared? And the answer for that is negative 3x. I write that in here. X times negative 3x is negative 3x squared. 2 multiplied by negative 3x is negative 6x. That is written here. Again, I put the line in, and I'll do my subtraction. Negative 3x squared take away negative 3x squared becomes 0x squared. Negative 4x take away negative 6x ends up being negative 4x plus 6x, which is 2x. And 4 take away 0 is 4. I repeat this process. I've now got 2x. What do I need to multiply x by to get 2x? And the answer for that is 2. So, x times 2 is 2x. 2 times 2 is 4. I do my subtraction, I get 0. So there's a remainder of 0 here. What does this tell me? It tells me that if I start off with this cubic and I divide it by x plus 2, I have a remainder of 0. So in other words, it fits in neatly. But the result of this will be the quadratic x squared take 3x plus 2. Let's take a look at a more complicated one, C. Here I have 5x cubed minus 13x squared plus 28x take 40, and I'm dividing it by 5x take 8. You know what the answer is here, but how do I do it using the traditional method? I set up my red grid. I write in the top line of the fraction, in this case it's a cubic. I have the bottom line of the fraction written here, the linear, and I work through systematically. Remembering there's nothing up here at the start or down the bottom. So, I've got 5x cubed. Here I have 5x. What do I need to multiply 5x by to get 5x cubed? And the answer for that is x squared. So 5x times x squared is 5x cubed. I write that there. Negative 8 times x squared is negative 8x squared. That goes here. Put a line there. Now let's do the subtraction. 5x cubed take away 5x cubed is 0x cubed. Negative 13x squared take away negative 8x squared becomes negative 5x squared. 28x take away 0x is 28x. Negative 40 take away 0 is negative 40. I repeat the process. I'm looking at this line now, and the first term of it, negative 5x squared. Starting with 5x, what do I need to multiply that by to achieve negative 5x squared? And the result for that is negative x. 5x times negative x, negative 5x squared. Negative 8 times negative x is going to be positive 8x. Again, we do our subtraction, they will go. 28x take away 8x is 20x. Negative 40 take away 0 is negative 40. I'm now looking at this line. What do I need to multiply 5x by to achieve 20x? And the result for that is 4. So I put the 4 here. 5x times 4 is 20x. Negative 8 times 4 is negative 32. Do the subtraction. I have negative 8. So I now have a remainder of negative 8. What does it mean? if I've got this cubic, I divide it by that linear. I'll get x squared take x plus 4 with a remainder of negative 8. So what does it tell me overall? Here's the cubic, here's the linear. It's exactly equal to the quadratic x squared take x plus 4 plus negative 8 over 5x minus 8.